Hey there, Mr. Leatherwood.
I'm Mrs. Weeks.
And we're continuing our week talking about mixed numbers and improper fractions. And today we're going to turn mixed numbers into improper fractions.
Awesome.
Okay. Just to refresh you, a mixed number is any number with a whole number and a fraction. And an improper fraction is?
Has the larger numerator on top of the smaller denominator.
Very good. Okay, so some examples to get you started. So let's say we have 5 and 3/5.
Okay. Which is a mixed number.
A mixed number. We're trying to get rid of the whole number, basically, and make the numerator or the top number greater than the bottom.
Exactly.
Okay.
And we need to mention again, what will always stay the same?
The bottom number,
That's
the
right.
denominator.
That denominator will always stay the same no matter what we do.
So again, you can use models. It takes a while, but you can. So we know that we're cutting them into fifths.
Right.
1, 2, 3, 4. And when I do this, my models aren't always going to be exact.
Are you saying you're not perfect, Mr. Leatherwood?
I wouldn't go that far. I mean, let's be honest. But I mean to not make them exact.
I understand.
Yes. All right, so then I made all these because I know that I have at least 5 of them.
Yes, that you filled up. Yes.
At least 5 of them. So I'm going to go ahead and color those in, and I'm going to be sloppy about it. So I know that all these 5 are colored in. And then I know from the other video that the 3 is my leftover. So I'm going to color in 3. Right?
Right.
Okay. And how this helps us is we can basically skip count, can't we?
Yeah.
Like, this is a group of 5.
5, so 5, 10, 15, 20, 25.
So we know that we have 25, but then we also have 3 more. So that would be
6, 7.
There you go. Nothing wrong with that. So I have 28 over something.
And that's what we said in the very beginning, though. We don't mess with the denominator.
Yeah. Denominator stays 5.
Stays 5.
Okay. So the improper fraction that is equivalent to 5 and 3/5 would be 28/5.
Yep.
So that's the model version.
And we're using with the model.
All right. So one more way. Okay. So let's do 4 and 6/7. Okay. This is also a slower way. And then there's a third way that I want to show.
Okay. All right. So I'm very excited. What is a slow way?
Slower way. Okay.
Because I know they're going to jump all over this.
Yeah, exactly. Yay! Slow way. Okay. So I know a whole number is like 1 over 1, 2 over 2.
Right, exactly.
100 over 100, whatever.
Exactly.
Okay. So I have 4 whole numbers. So I could write a number sentence. 7 over 7
would
equal 1.
Right.
And the reason I picked 7 is because
that's our denominator. That's the parts that we're going into.
So I know I have 4 of these.
Because each of those, 7 over 7, represents 1.
Yeah.
There we go.
So I have 4 of those. Yep. And then I also have 6/7 left over.
Right.
Okay. Okay. So in a week or so, we're going to teach you how to add fractions.
Right.
And when we do, we're going to let you know that the denominator never changes.
Right, exactly. When it's all the same denominator, it's going to stay the same.
So to get the top, we just have to add the numerators.
That's right.
So 7 plus 7 plus 7 plus 7 is 28.
Right.
And then we add our 6. 28, 29, 30, 31, 32, 33, 34. Right? Hey, nothing wrong with count by ones, right? So 34/7.
Stellar mathematicians.
Yes.
That's what we are.
Okay. So our improper fraction would be 34/7.
It's because you're wearing an OU shirt.
Is that what it is?
Yes.
So this is, I call it the slow way because you're having to write out these. I mean, imagine if this was 25 and 6/7.
Yes, and you would.
I would have to write this out 25
times. Yes.
Very valid.
Yes.
We're going to show you kind of a shorter method.
Right.
Though.
Exactly.
All right. So our shorter method.
All right.
5.
5.
5 and
4/6.
Ooh, good. Perfect. 5 and 4/6.
Yep.
Okay. Should have made it bigger. That's okay.
Okay.
This is okay.
That's
Okay.
good. I'm glad.
So the short way, okay? Bloop. You're like, what the heck
Yes.
is that? Okay. So you're going to go this way. 6 times 5
Right.
is 30. Right?
Uh-huh.
Okay.
Plus
Plus 4
is
equals
30.
34. Bottom number,
Stays the same.
34/6.
Right.
Simple.
And basically, they should understand that you're having, just like you did the repeated showing the 7 sevenths that many times, that's the same as multiplying. So you're doing 6, 6 basically 5 times
Right.
to get, and then adding in, because you can't forget that you only had part of.
So instead of doing this,
Exactly.
you can see how it could get long.
Yes.
This right here
Yes.
is the 6 times 5.
Right.
Because you're doing 5 groups of this.
Yes,
six over
exactly.
6.
Exactly.
And then you're adding your leftover just like we did
Right, with the
a second
4.
ago.
Yep, with the 4, 6.
Okay.
So-
So you're adding this, which is just this right
Right.
here.
So if you look at all those numerators, just like you would have added them, we're
Mm-hmm.
just doing 6 5 times, and then we're adding in that 4, and the denominator's going to stay the same. So,
And
awesome.
When I was a kid, my teacher she gave me this little saying, you always cross the railroad track before arriving at the hospital. And you're looking at
She
me.
worried you'd end up in the
Yeah,
hospital.
probably. Let's be honest. Okay, so, and the reason that is if you look at a railroad track sign, it kind of looks like this.
Yes.
So that would be the multiplication.
Right.
And then if you look at, you always think of a hospital, they have that red cross.
Right.
So she said if you cross the railroad tracks before arriving at so that kind of helped.
Yes.
It's cute.
It's adorable.
It's adorable.
It's adorable.
Should we do one more?
I think so.
Okay, one more.
Yes. Let's.
Okay, so let's give you one to mess around with a bit.
Okay.
3 and 7/12. Is that okay?
Yes, I think that's perfect.
Kind of tricky.
Yes.
So go ahead and pause the video, try it, and we'll come back and let you know how it works.
Yes. We'll just hang out here.
And we're back. All right. So we're going to do the short way.
Okay.
Because the long way is boring. And I'm going to
Yes.
do this.
You weren't telling them that, though, right?
No, it's exciting.
It's exciting.
Well, I think it's good to show the meaning behind it.
Exactly.
I don't want to
Absolutely.
show. I hate showing shortcuts if there's not meaning behind it.
Right, exactly.
So we could do both. This one's a whole number of 3. It could be really easy to do, but we can. So we're going to multiply on the bottom,
Railroad track.
and we're going to add on
In
the top.
hospital.
There you go. They'll remember it. Remember, you're always going this way.
Yes.
Okay. So 12 times 3 is
36.
plus 7. See, not as quick. You laughed at me counting by ones earlier. So 36 plus 7,
43.
43. Very good.
Yes.
She used humor to wait to add it. in
Yes,
her
I
head.
did. But at least I was doing it in my head.
And the bottom number,
Stays the same. It's gonna
always,
be 12.
always, always.
Yes.
So that'll be your
Yes.
answer. Long way. Or maybe I should say the right way.
Uh-huh.
If you were really going to
Yes.
do this.
So you're doing the 12 12s 3 times.
And
And then don't forget that you have part of it, the 7 12s. So 12 times 3 plus the 7 will give you the 43 12s.
So same answer. Okay.
Yes.
And you could do models too.
That's right.
I don't-
Railroad Tracks Hospital.
Yep. I would do the models, but 12ths I'd probably mess up. To be honest.
Goodness
I guess
knows.
I could do 6 and then cut them in half. It wouldn't be too bad. Anyways,
They'll be here all night.
yeah. That'd be
Yes.
So try some more. Get your parents to give you some random numbers and multiply and add, multiply and add. Multiply and
Work,
add.
work, work.
That's right. All right. Thank you. Bye-bye.
Bye.
Oh, you.